Hello, my name is Heidi Gastol and I work in the Informatics department at Waters. Today I'm going to show you how the Waters BioRecord, which is an LC-MS system, can interface with the Sartorius AMBER 15 bioreactor systems. So this is using the data interface license within our Waters Connect software. The first step is at the AMBER 15 system. So the user configures an AMBER study as normal. For example, this could be a clone selection study or maybe looking at process optimization. In their AMBER 15 study, they include aspiration steps, and they may set this up to happen every day or every 2 days. Once the study is running, the AMBER 15 takes samples from the vessels automatically and generates a CSV file with the location and the information for each sample. It shares that CSV file in a folder that the BioRecord can access. The user then removes the plate from the AMBER, and they may perform some simple sample preparation steps such as centrifugation. They then put the plate into the BioRecord and are ready to analyse their samples. To do this, the user logs into the Waters Connect software on the BioRecord PC. Waters Connect is a software hub and you can choose which apps you want to have on it. Today we will use Sample Submission and IntactMass. When the user opens IntactMass, they have an option to acquire data and process it. And this now opens a wizard. And they're going to choose the workflow for bioprocess system integration. They then just need to give their analysis a name that is sensible to them, and then click Acquire using Sample Submission. This then opens a new tab with the Sample Submission application, which is what we use to submit our sample list. So on the left-hand side, we need to select the BioRecord system that we are using, and we need to identify where we keep our methods. So we have a file structure so that you can keep hold of your methods and keep them nice and organised. So I need an acquisition method, and I'm going to use my processing methods from this folder. Okay, if you are using a different kind of tray, you can select it from the drop-down menu. So for example, there are 96 well plates and 384 well plates. We also need to tell the BioRecord which method it will use initially. So this is what I'm going to start with, and then we can set it going to the initial conditions while we set up our sample list. Okay, now it's time to set up our sample list using the CSV that the AMBER system exported for us and that the BioRecord has been able to access. So to do that, we go to Import and Sartorius. And then we can access that shared location and open those CSV files. When we do that, if I scroll to the right, so you can see that all of the information from the AMBER 15 system has been brought in, including the time that the samples were taken, what time they were aspirated, their location and position, and the name of the experiment in the AMBER 15 and on which plate. If I scroll back over to the left, you can see that each injection which will be analysed on the BioRecord has now been given a name that relates to where it came from on the AMBER 15. For the first injection, if you like to run a blank, then you can do. So you can select blank here, and if you would like to use a specific acquisition method for blanks, you can do. We know some customers like to do that. However, you don't have to do, so you can just start with your samples. So what we need to do is to tell the BioAccord how we want the data to be acquired and how we want it to be processed. So it's an unknown sample type because we've not analysed this sample before, and I want to inject 1 microlitre for the LCMS analysis. It's already got its sample position. I'm going to say which method I want to use for the LCMS and which method to process the data. And then finally the masses that I expect for my molecule. So once I've got all of that information in, I just want to fill that down for the rest of my sample list and do this one here as well. And then we are good to go. So we'll just press save. And that's saved the sample list, so we could use it again if we wanted to do, and then we're going to hit submit all rows. That has now been submitted. I can see that my samples have gone through to my queue. And if I open Intact Mass, I can see that the first injection has been added to my list in Intact Mass, where it's going to process the data. And it will then start to update me on the progress of that injection. Once the analysis has finished, the results look like this. You can quickly check your results, or you can click to look at the results in more detail if you would like. But you may want to come straight down here to create summary reports. And we're going to click the Sartorius template. So this formats this table in the format that is needed by the AMBER 15 system to import it. So that's all of our results for all of our samples. And we can now export it to that location that is shared with the AMBER, and it will then be accessible by the AMBER 15 control software. Okay, so that's successfully exported. So let's go back to the AMBER PC to have a look at the results. Okay, so back on the AMBER PC, we can now navigate to the In folder, and we can see that the BioAccord has exported a CSV to share with the AMBER. The AMBER monitors this location and automatically imports it if it has the right configuration. Then if we look into the AMBER control software, we can see that the values from the BioAccord have been imported into the AMBER. These values are the relative percentage of each modified species. So in this case, I've been analysing a monoclonal antibody. So the major modifications are glycans, and I can monitor the relative abundance of the different glycoforms. These results can then go on to be visualised in the plots in the AMBER control software, so that you can see how the relative abundance of each species is changing each day or across the vessels. For example, you may want to compare different clones, and with these results you could identify which clone was giving you the desired profile that you're after. Or you may want to monitor the amount of an undesired modification over time. For example, if you want to check for sialylation or cysteinylation, so that you can choose the best process parameters. You may also want to combine the information from the BioAccords with the readouts from your other probes or other analytical techniques. Last but not least, the AMBER can take action based on the results from the BioAccord. So this is using the conditional steps within the AMBER control software. For example, if the LCMS results show that you have a high amount of mannose 5 in vessels 5, 6, 7 on the second station, then the AMBER 15 could follow the conditional step and add more of a particular feed to those vessels. So the process can therefore be optimised automatically during the study, which means that you can increase cost and time efficiency. So that was a quick overview of the WatersConnect software data interface for the AMBER 15 system. Thank you for your time, and I hope it was useful.